EE8, we're going to cover EE.8a and b, and this is all within systems of equations. Number 1, how many solutions does the system of linear equations have? Notice they're both in slope-intercept form, and they have different x terms. This means they also have different slopes. If two lines have different slopes, then they will cross somewhere at exactly one solution. Number 2, this system has no solution. That means they have the same slopes, different y-intercepts, which means they're parallel lines. So if these must be the same slopes, then that means that m has to also be 2/5, and we know that because it has no solution. Number 5, the total cost C of belonging to two different school clubs for m months is shown on the graph. What is the solution of the system, and explain what this means? The solution is where the lines cross. They cross where x is 4 and y is 125. So that's the first answer. And what does this mean? This means at 4 months, the cost is $125 for both clubs. Which that means they have the same cost at that point in time. Number 6, solve the system of equations algebraically. This just means solve without graphing. You could use substitution or elimination. Looking at this, elimination would be the easier method to use, but you could use either because your x terms line up, your y terms line up, your equal signs line up, and your constants line up. So I would like to eliminate the y's because they're the same, and I can eliminate very quickly by just multiplying that bottom equation by a negative sign. So I've got 5x plus y equal 4 for the first equation. It doesn't change. Multiplying everything by a negative sign makes this negative x minus y equal positive 4. And so when we add the two equations together, the y terms are opposite, so they equal 0. We get 4x equal 8. Then divide both sides by 4 to get that x is 2. Now we always go back and get the other variable when we're trying to get the solution to a system. I can pick either equation. I'm going to choose the second equation, x plus y equal negative 4. I'm going to plug in 2 for x and then solve for y. So y is negative 6, so the solution is where x is 2, y is negative 6, and we've solved the system. Number 9, solve the system of equations by graphing and write the solution. So this first one, I'm going to identify the slope is 1 and the y-intercept is negative 4. So we begin at b, the y-intercept, which is negative 4. And the slope 1 could be written as 1 over 1, which means we're going to rise 1, run 1 to the right, that's positive, and we keep doing that all through the coordinate plane from edge to edge. Then draw a line for that equation. For our other equation, number 2, the slope is 1/3. B, if we don't see what's added to it, it must be 0. So we're going to begin at 0, and then go up 1, right 3, up 1, right 3 through the coordinate plane. The other direction is negative 1 over negative 3, so we go down 1, left 3, and draw a line through the points. The two lines cross here at 6, 2, and that's the solution to the system. The next the next page is about specifically EE.8a, which is about graphing. Number 1, how can you tell if an ordered pair is the solution of a system of linear equations by examining the graphs of the solutions? Well, in simple words, an ordered pair is a solution if it falls on both lines. And in most cases, it's going to fall on both lines in one place in a one solution answer. So it's just where both lines pass through the point represented by the ordered pair. Sometimes you do have multiple points, which would be where both lines are the same line and you have an infinite many solutions. Number 2, does this ordered pair, negative 5, 3, satisfy the system of equations? Well, we would start by noticing that this is an ordered pair, x and y. And I'm going to take each of these equations. I'm going to start with this first one. I'm going to say, okay, y equal negative 2x minus 1. where y is 3, x is -5, and we get 3 equal 9, which is false. So that one's false. Looking at this other one, we just plug in and say y equal -3/5 times x. Well, y is 3 equal -3/5 times x, which is -5. And -3/5 times -5 does come out to 3, so that one is true. So is this the solution to the system? Well, we know it can't be because one of those was false. So it's not answer choice A. And it happens to be answer choice C. No, because this ordered pair, -5, 3, satisfies only this second equation. Means it's only true for that equation. The next little standard, EE.8a-b, specifically focuses on solving a system. We're going to look at number 1. It says, what solution does this system have? Notice that in both cases, the second equation is a multiple of the top equation as far as your x terms. -4 is 2 times -2. Your y terms, 10 is 5 times 2. So I'm going to multiply that top equation by -2 so I can get the same coefficients but opposite signs. So I get 4x minus 10y equal -20. We will add that to -4x plus 10y equal 20. When you add them together, you'll notice that the x terms and the y terms both cancel out to 0, and so does the constants. So we get 0 equals 0, which is a true statement, which means there are an infinite number of solutions because we got a number equal a number that was true. Number 3, Trudy and Xander are saving money from their newspaper route earnings. Their savings S in dollars are related to the time T in weeks after they start working. Trudy's savings are given by the equation S equal 40T plus 50. And Xander's savings are given by the equation S equal 35T plus 100. What's the meaning of the solution? Well, to get to the meaning of the solution, we've got to find the solution first. So I'm going to use substitution on this problem because I've got equations set up in S equals something, or if I had X equals something, or Y equals something, it's easy to use substitution there. I can immediately notice that I've got an S for both of those, so I'm going to say, well, S is equal to S. So S is equal to 40T plus 50. S is also equal to 35T plus 100. This is now just an equation that uses one variable T that I can solve for T. So I'm going to get rid of one of these variable terms. I'm going to subtract 35T from both sides. The result is 5T plus 50 equal 100, which is now just a two-step equation. I want this T term by itself, so I'm going to subtract 50 from both sides. I get that 5T is equal to 50, and then dividing both sides by 5, T is 10. Now last, we just need to get the value for S. So I'll pick either equation. I'm going to choose the top equation and say, well, S is equal to 40 times T plus 50, where T is 10. So S is equal to 450. Now we found the solution, but we need to find the meaning. The meaning's pretty quick here, however. Notice that S is the savings in dollars. So I'm going to note that means $450 saved. And then T is the time in weeks. So that means that's 10 weeks. Looking at our answer choices, C and D use completely different numbers. But when we read them carefully, and A says they both have $450 saved after 10 weeks, which is what our answer is. Number 4, determine the number of solutions of each system of equations. Well, notice that choice A, they are the exact same equation. So there are infinitely many solutions because they are the same equations. Looking at choice B, we're going to zoom over here and work it out. Choice B, we have x plus y equal 5, and -2x minus 2y equal 10. So I'm going to choose to get rid of my x's, but it will get rid of both x and y in this case. Because I'm going to multiply the top equation by 2. I get 2x plus 2y equal 10. The bottom equation stays the same, negative 2x minus 2y equal 10. And when we add those together, x and y both cancel out, we get 0, but 10 plus 10 is 20. So that's a false statement. So that one will be no solution. Problem C, we have x plus y equal 6 and x plus 2y equal 6. So I'm going to get rid of my x's, is what I'm going to choose. They're the same, so I need to change to the opposite sign. So I'm going to multiply this bottom equation by a negative sign. So the top equation stays the same, x plus y equals 6. The bottom equation multiplies everything by a negative, so it becomes negative x minus 2y equal negative 6. Add the two equations together. The x terms eliminate, but the y terms do total to negative y, and then the constants eliminate to 0. Divide both sides by negative 1 to get y by itself, and y is 0. That tells us we're going to have one solution because we got x or y equal a number, and we don't have to finish because we have determined the number of solutions, which was all it was asking for. So we have no solution, and we have one solution. We're finished with these notes.